We're looking here at an interactive simulation that calculates the heat reaction as a function of temperature, and it does this by calculating enthalpies for reactants and products, how they change with temperature using temperature-dependent heat capacity. So simulation looks like this, and just want to point out that the slider for temperature allows us to see the value of the heat reaction at a given temperature. So you'll notice we're plotting enthalpy on the x-axis and temperature on the y-axis. So enthalpy increases as temperature increases for both reactants and products. So the heat reaction doesn't change dramatically with temperature. So let's look at the interactive simulation. So here's the interactive simulation for acetylene hydrogenation. You'll notice if we increase the temperature by moving the slider, the magnitude of the heat reaction becomes larger, it becomes a more negative value. But even over 800 degree temperature change, we get a small change, about 5% change in heat reaction. So you can see why often we assume the heat reaction is a constant. Likewise, if we look at the heat of reaction for carbon monoxide over a wide temperature range, first thing to notice is that the heat reaction actually becomes smaller in magnitude, less negative, but the change is only about 2% over 1200 Kelvin. The Haber-Bosch process, and let's look at that, that's a little different in that as we change the temperature over maybe 800 degrees, the heat reaction becomes more negative, but it changes about 10%. So it's large compared to some of the others. But still, over a reasonable temperature range, we often assume the heat reaction is independent of temperature because of these relatively small changes.